the multiplier. As you can see, I still have the stuff on the board from the injections leakages lecture. Man, when I stopped the video, I thought, I'm getting hungry. I bet it's lunchtime. It's 10 o'clock. It's not lunchtime. So I'm going to have to hold out. At least make it through this next video. All right, this next concept, for which there's also another handout that I typed up that's available on the webpage, is the multiplier. You probably had this in an intro class, although I say that you're not required to have taken intro macro for this class. Only intro, any intro class is enough. We decided that some years ago. We used to require, for what one would think obvious reasons, intro micro for intermediate micro. In fact, I think we required both intro classes, and then intro macro for intermediate macro. And then we decided, you know what? The classes are so different. What we really want is for you to be experienced with economics. I don't care which class it was, just have some experience, do some economics, and then we're going to take you to a different level in this class. So anyway, point being, you don't have to have had intro macro for this, so maybe you haven't seen this. This is the income multiplier. When you hear economists just say multiplier, they mean the income multiplier. There is another multiplier, the money multiplier, but that always has the adjective money in front of it. But if you don't hear the adjective in front of multiplier, then they almost certainly mean income multiplier, and that's what we're about to do. And the basic concept is that injections, again, when one of those injections goes up, the impact on income, remember I showed you last time, injections greater than leakages, that causes income to go up. How much? It turns out by a multiple of how much the injection went up, all right? And here's why. I showed you that. Oh, by the way, we're no longer going to use AE. Remember I did that for aggregate expenditure in the last video? And aggregate expenditure was equal to income. Well, we're just going to use Y. We're just going to use Y for everything now. They're equal. We're going to use Y all the time for income, output, expenditure. All right. So we're just going to use Y. And by the way, when they add up GDP every year, they add it up via an income approach. They add up everybody's income. They figure, aha, that must be the total spending in the macroeconomy this year because it's also the total income. And of course, you turn in your income taxes, so that's how they get those numbers. Also, firms have to report how much they sold. So they can also add up all the expenditures, and they do both, all right? Theoretically, you should get the same number, but people like round off and stuff like that. So, but they know they should be getting the same number. So this isn't just sort of a practical application of the idea that income and expenditure must be the same number at the macro level. All right. I done already showed you this here equation. C plus I plus G plus X minus M. That is our equation for all the kinds of possible spending. By the way, each one of those individual variables too also is income, output, and expenditures. Each one of those individuals. This is the total dollar value that households expended on consumer goods. It is also the total amount of income earned by the consumption goods industry. All right? Does that make sense? That this number here is not only how much households spent on consumer goods, it's also how much income the consumer goods industry earned. And it's the dollar value of all the consumer goods that the consumer goods industry sold. Likewise here, this is how much firms spent on investment. It is also how much investment firms earned from investment. Right? Let's see, government spending. Yeah, same thing. That this is how much the government spent. It's also how much those firms that sold stuff to the government earned. So it's spending and income at the same time. All right. So not only is it true of Y, it's true of each of the individual variables that it is simultaneously total income, total expenditure, and total output in that sector, or here in that sum of all sectors. All right. So what we're going to do now is say something more specific about something that isn't one of the injections or leakages, consumption. And let's start like this. In order to come up with the multiplier, I think I even put a graph in the handout. I was very excited. Let's see here. What do I want here? I want income and consumption. I mentioned in the previous video that at the macro level, the single most important determinant of consumption is simply income. Believe it or not, there's a very high correlation between how much money people spend and how much they earned, all right? And presumably, I didn't do it this way in the handout, by the way. I went a different direction, but I'm going to do it this way here because I felt like in the handout it would get a little bit too tedious. Whereas you could put this video on double speed, and tedious isn't as bad, is it? But at very low levels of income, how much of your income do you have to spend? All of it, all right, in order to survive, all of it. So it's like a 45-degree line down here, assuming we're measuring these in the same units. And then eventually, people want to save. People would like to have some money left over. They don't want to spend every penny of their paycheck. So eventually it levels off. So this is the consumption function. Consumption is a function of Y. But it's not a straight line. And so as a consequence, it's kind of hard to come up with a nice simple equation for it unless you do this. This is not one of Dr. Elliott's classes. It's not development. We're talking about, generally speaking, I think always speaking, developed economies. So we're not going to be in an economy where everyone has to spend every penny. So let's say, we'll call it Y star. Let's say we're only dealing with economies that are Y star big or bigger. Well, if we're only dealing with economies that are Y star big or bigger, then that red line is not exactly on top of the purple line, but it's awfully close, right? So that red line approximates how much money people will be spending from income in developed economies where we don't need to spend every penny just to survive. And let's extend that. Aha! Now we have a vertical intercept of A. Now I do say this a number of times in the handout. Don't worry about A. A is not really an important variable. As you can see here, it is really the result of us making a simplifying assumption. That is, that the line looks like the red line and not like the purple line. In reality, it looks like the purple line. But if we're dealing with economies Y star and bigger, then we can pretend that we really just have the red line and we don't lose anything, all right? And the red line has a different equation. C equals A plus B times Y. That's a very specific equation. It's still C is a function of Y, but now it's a very specific function of Y. It says that consumption is equal to A plus B, which is the slope of the red line, times Y. Let me show you that. Check this out. Sorry, pen. C equals A plus B times Y. A. Okay. Let's say we have this level of income right here. Let's call it 50. And let's say that A is 10, and we're going to let B be equal to, I don't know, 0.5. All right. So, if B is 0.5, then how big is that? If B is 0.5, then we know we've got 10 so far for consumption. Right? Consumption is going to be equal to this number over here, which for now we'll put down as a question mark. Consumption is going to be equal to that number. Well, we know the number is going to be at least 10, right? Because consumption is equal to A plus B times Y, and A is 10. So we know it's going to be at least 10. How big is that part of it right there? Well, that part of it right there is 50 times the slope. Because if you think about it, the rise over the run is going to give you the percentage of this that shows up over here. That's what the slope is. And so since it's 0.5 times 50, it's 25, all right? So that distance up there is 25, so it turns out that we don't have a question mark here, we have 35. 35 is the level of consumption when income is 50 trillion, whatever you want it to be. Actually, that wouldn't work, 50 billion. Let's see, that's how the equation works, all right? That you plug in the level of income, and then if you're given A and B, which you would be, then you'll find out that, consumption is equal to 10 plus 0.5 times whatever income is, right? That's what if income's 0? Then 0.5 times 0 is 0, consumption is just 10. And then for every $1 in income goes up, consumption is going to go up by 50 cents. Which means that this essentially shows you how much consumption rises for every dollar increase in income. It is what Keynes called the marginal propensity to consume. It's what you do with any new income you earn, right? How much of it do you spend? Now, yeah, okay, that's good. Now let's plug that in. All right, so there's where the equation comes from. Now let's write that out. Let's have that as a second equation here. C is equal to A plus B times Y. Now, let's substitute A plus B times Y into the first equation for C. Y is equal to A plus B times Y plus I plus G plus X minus M, right? Now let's solve for Y. Get all the Y's on the left-hand side. A plus I plus G plus X minus M. Factor Y out. Y times 1 minus B equals A plus I plus G plus X minus M. And then divide both sides by 1 over B, or multiply both sides by 1 over 1 minus B, which is the same thing. A plus I plus G plus X minus M, like that. Voila. Now we have the multiplier derived. This is the multiplier. Income multiplier. What this now shows is, and remember A is really kind of irrelevant. Notice we've got the 3 injections over there on the right. Let's see if the green shows up very well. We've got the 3 injections on the right. So what we're going to find out is how much is total income going to change for a change in one of the injections. Let me stop and say something about M real quick. As you may wonder, why is one of the leakages continuing to show up over there? And this is explained in the handout. The problem is this. Why do we have a negative number in GDP? I mean, if this were 0, 0, 0, and 0, could GDP be negative? No. The problem is this. When we measure consumption, we're measuring total consumption, including anything people imported. Total investment, including any investment goods firms imported. Total government spending, including anything the government bought from other countries. So that M right there, that negative M, is really to draw out of these 3 over here all the things that were purchased from foreigners and not from Americans, all right? So the reason why we have a negative M in there, the reason why there's a negative number in GDP is because these included imports. These were total spending by your household, not taking into account where the stuff was bought. Total spending by the firms for investment goods, not taking into account where it was bought. Total spending by the government, not taking into account where it was bought. Now we settle up. Now that M there is drawing back out of that all the C, I, and G, not X obviously, all the C, I, and G that was actually spent on foreign stuff, all right? So that may make you wonder, well, why don't we just measure this as domestic consumption? Well, then that causes problems too. But we're going to have a problem one way or the other. And I won't go into the problems it causes because it's just going to be confusing, but either we do these as only domestic spending, or we subtract the M out at the end. There's either way, it creates a bit of a problem statistically. This is the way we've decided to go with it. Right. So why is there a leakage in that equation? Because these injections included part of the leakage. Right. So anyway, let's see. Let's get back to this. All right. So what we've got here. Let's use that example I just had there, where B was 0.5. 1 over 1 minus 0.5. All right. B was 0.5. Remember, B there is the percentage of new income you tend to spend. All right. So B is that percentage of new income you tend to spend. And in that example I just gave you, it was 0.5. All right. So what is 1 over 1 minus 0.5? Well, it turns out to be 2. 1 over 1 minus 0.5 is 1 over 0.5, which is 2. So if the propensity to consume is 0.5. Then for every dollar increase in investment, total income actually increases by $2. For every dollar increase in government spending, total spending actually goes up by $2. Again, we're going to net out anything that was spent on foreigners at the end there. But let's just say, for simplicity, this is pure domestic consumption that's going, or pure domestic spending that's going on here. Any spending that foreigners do on our stuff, for every dollar they buy of our stuff, it actually raises our income by $2. Watch, I'll explain that in just a moment, but let me give you another example here. What if people tended to spend 75% of their income? All right. Well, now we've got 1 over 1 minus 0.75, which is 1 over 0.25, which is 4. Aha! The more people spend, the bigger the multiplier gets. Let's do 0.8. Let's do 0.9. What the heck? Now we've got a multiplier of 10. The bigger this B is, the bigger the multiplier is, therefore the bigger GDP is, even given the same amount of I, G, and X. Why? Well, I'll tell you why. Again, this is all written out on that handout on the web page. I have a bunch of examples and so forth. I believe I even discuss what the number might be actually in real life for the United States of America. Okay, let's say in this example that B is 0.5. And let's say that what happened was there was an increase in investment of $10, all right? TCU bought a new doorknob for one of the buildings, for that new performance hall building, all right, for one of the doors in the performance hall. So they spent $10, right? So this $10 was both the increase in investment and new income for the company that sold the doorknob, right? TCU increased investment by $10, which created $10 worth of new income. Now, how much do people tend to spend in this economy? 50% of it. So, the people who receive this income go out and like, oh, this is great. We got $10 more. Let's go spend 5 of it. All right. So this is an increase in consumption and new income. Because what happened was that as the manufacturer of the door handle got $10, obviously it's a little bit more complicated than this, but the story is still consistent. This is one of those close enough times. We could really break this down into costs and profits and wages. but it'd still be the same story. It would just take a heck of a lot longer to get there. TCU spends $10 on the new doorknob, which is investment for us, new income for the doorknob manufacturer. Doorknob manufacturers go to Walmart and they spend the $5 there, all right, on new fishing equipment, all right? So that for them was consumption, and that created new income for Walmart. And then Walmart goes out and spends the money at Target, all right? So this is another increase in consumption, which is going to be new income for Target. And on and on and on, right? So the initial injection of $10 created $10 worth of income, and then because somebody spent that, now it's $15 worth of new income, and because somebody spent half of that, now it's $17.50 of new income. Now, what is the number eventually going to be if we continue to make this calculation here? Here's the exciting part. Who am I kidding? It's all been exciting. Take that multiplier, and since in this case the propensity to consume was 0.5, we'll do 1 over 1 minus 0.5, 2, right, is the multiplier. The eventual total increase in income from TCU increasing investment by $10 is going to be 20 bucks. You find out by multiplying by that multiplier. I can't remember, I end up doing this every time. It's some kind of expansion in math that says that if we take a number and sum, and multiply it by the same thing over and over and over and sum those, then you will get 1 over 1 minus whatever the percentage was you were multiplying it by. It's not a Taylor expansion. I can't remember what it's called now. Anyway, but that's where that comes from. That it turns out that the shortcut to figuring out the sum of each of these things marked in red, and of course, and continuing on down until they're too small to calculate, turns out it's going to add up to 20. We're already to $17.50 just after 2 spending rounds. TCU invested, and then we had the spending round and the spending round. And so you get there pretty quickly, depending on the multiplier. But the shortcut to getting there is to simply multiply the first number by 1 over 1 minus that number, and that's the multiplier. All right? And this is a very handy concept in real life. There's a guy down at, well, he used to be at Baylor. He's now just been in business for himself for a long time. M. Ray Perryman. I just emailed him the other day. And he does economic impact reports or studies. For example, let's say you were wanting to build a new stadium in Irving, and you were wanting to convince the city of, let's put it in Arlington, I forgot. The Cowboy Stadium used to be in Irving. You want to, pardon me, my first water I've ever drank. You want to build a new stadium in Arlington, and you want to convince the city of Arlington to help you pay for it. Well, then you hire M. Ray Perryman to do an economic impact report. And what they're going to do is they're going to say, well, for every dollar spent on the stadium, it's going to cause X more dollars of spending in Arlington. For every person that comes in to see a Cowboy game, it's going to create X more dollars. Guess what they use? They use multipliers. All right? M. Ray Perryman is going to draw on statistical analyses and regression analysis that have been done in previous studies and say that, well, it's probably going to be about the same thing in Arlington, all right? So these are actually used in real life. I used to live in Indiana for a while. Let's see, this was actually in between undergrad and grad school, so I just kind of went home for the summer and then left again back to the University of Tennessee. But my dad was working for a plant there, a company called Peyton's, which was a subsidiary of Kroger's. And they would have the big warehouse. And so when a Kroger store or any other store that wanted to sign up for their service wanted non-foods, this was non-food stuff, then they would send the order to this warehouse and they would fill the truck with the stuff and send it off. Man, the city of Bluffton, Indiana could not do enough for Peyton's, all right? Hey, we'll build you a road. hey, we'll walk your kids to school every day, because they desperately needed. They'd already had a big factory shut down, Corning glass factory shut down there, and they wanted this other factory. Now, and it wasn't just people who were going to work at the warehouse that were excited. It was everybody else in town. Why? Because of all this, because of the multiplier effect. Because when you take your paycheck at Peyton's, not only has that increased income in the community of Bluffton by the amount of that paycheck, now you're going to go to the Kmart that was right there in town. All right? Now you're going to go to the liquor store that was there in town. What else was in town? I can't remember anything else. There was a really good restaurant right on the Wabash River right there. And so you're going to go there. So the people who ran the restaurant there were very excited about this new warehouse being built because it was going to raise their incomes too. Right? Why? Because of the multiplier process. So, for our purposes in this class, the big important thing is that now, man, these what do you call them, injections are taking on even greater importance, right? Not only are they in the driver's seat determining how large or small GDP is going to be, but also for every dollar they change, the final change in income is going to be a multiple of that dollar. And for the U.S., probably in the range of 2 to 3, right? Depending on the kind of spending that took place. Okay, I was going to combine this with another video here on, or explanation here on the balanced budget multiplier, but I think I'm going to break it up. All right, so I'm going to stop it right here at 26 minutes. It's still not lunchtime though, is it? I'm hungry.